Now we want to take a look at a couple of cases where we'll end up with no real solutions, so we can see what that looks like and understand how to recognize it. In example 5, we have x squared minus 4x plus 8, where each of those coefficients will give us our values for a, b, and c. Setting up the quadratic formula, we'll have the opposite of negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 8 all of that over 2 times 1, which will give us positive 4 plus or minus the square root of 16 minus 32 all over 2, which will simplify to 4 plus or minus the square root of negative 16. All of that over 2. In this case, we have a value that's less than 0 under our radical, unless we again get into complex or imaginary numbers. If you've seen those before, we can't take the square roots of negative numbers. We're only dealing with real number solutions. So in this case, we would simply say that x equals d and e does not exist. There are no real solutions to this equation, no real numbers that we could substitute in to make that expression on the left equal to 0. We'll have a similar circumstance in example 6, where our value for a will be 5, b will be negative 2, and c will be 6. Setting up the quadratic formula, we'll have the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 5 times 6. All of that over 2 times 5, or 2 times a. The two negatives will cancel out, so this will become 2 plus or minus the square root of 4 minus 4 times 5 times 6 will be 120, all over 10, which will give us 2 plus or minus the square root of negative 116 over 10. As soon as we see the value for the discriminant, the value under that radical is less than 0, we don't need to do any additional work, and we can say that x equals d and e does not exist. Because again, in both of these cases, there are no real number solutions to either of these equations.